Hey, what's up guys? In this video we're going to be going over the anatomy of a wave and how to read oscilloscopes. This is an oscilloscope. This is a signal analyzer from rs-met.com. It's free. And yeah, let's just get started here. So we have this center line here. This is called the point of rest or zero line. And this up here is called amplitude. And this is how loud things are. So, right? So at absolute zero, we're pressing keys, nothing's going on. It's close to the point of rest. The farther away from the point of rest, the higher the amplitude. Right? And this line is time. So point of rest over time and the amplitude, loudness. All right? You got that? We're going to start with the simplest of cycles, or simplest of waves, which is our square wave, right? So we have a, no, actually, we'll go this one first. This is the simplest of waves. This is a sine wave. This is what the universe is made out of. It's actually really trippy when you think about it. This is called the crest, the top part. And this is called the trough. So top is crest, bottom is trough. You'll notice that it repeats. Right, it's a very clean signal, no envelopes or whatnot, and what it is it just kind of repeats over and over and over again. All right, so let's look at that for a sec. So starts up here, repeats, and then begins again up here at its absolute peak. So it starts at its peak crest, right? Starts there. And in the oscilloscope here. So this will be called the wave cycle or the duty cycle, right? And then it repeats. And there's different kinds of duty cycles, right? We have our square here. It's obviously the same kind of duty cycle. The equal parts in the trough, equal parts in the crest, right? So what does this all mean? It's just, this is just what music is made out of. This is what your speaker is physically doing. It's going in and then out, in and then out. Wave cycle, or the wavelength, I should say. The wavelength is the distance between the peak of the crest and the peak of the trough. Right, so as you move down as the key, wait, so I'll do this better. There we go. If you shorten the wavelength, you go up in pitch. Right? So as you shorten the wavelength, you go up in pitch. Right? So in theory, a shorter wavelength, a shorter duty cycle means that it's a higher pitch. This is like the most boring video I've ever done. Anyway, with that being said, now you know the anatomy of a wave, right? And you can look at and understand that different kind of sounds here, different waves have different duty cycles and kind of have different crest and trough factors, right? So this is kind of interesting, looking at this pulse here. And of course, white noise is chaotic, and that really isn't a wave. It's just noise. All right. So why would you want to understand what a signal analyzer does, like an oscilloscope? Well, you can physically see what a filter is doing. What a filter is doing, what, say, distortion is doing, what, say, fold back. We'll turn off the filter so you can physically see what's going on there. And we'll do this to a sine wave. Fold back. Another thing I want to show you is Phase. So what does phase mean? Well, if you have two sine waves, okay, we'll go two square waves going on at once. Or we'll go two saw waves. These are two saw waves. Right, they're both going on at the same time. And of course we can like detune them. Right? But they're both starting at the same time. They're both being re-triggered at the same time. If we adjust the phase of one of them, they both start at different times, but they're still in time. Right? And that's kind of like an interesting sound there. Yeah, that's pretty much it. Hope you learned stuff. Take care and have a good one.